Okay, 8th graders. Today we're talking about exponential growth, and your essential question is, can you identify the characteristics of exponential growth? So let's first define it. Exponential growth occurs when a quantity increases by the same factor over equal intervals of time. And the exponential growth function is y equals a times 1 plus r to the power of t, where t is time, r is the rate of growth in decimal form, and a is the initial amount. So let's try one. The function y equals 150,000 times 1.1 to the t power represents the attendance y at a music festival t years after 2010. By what percent does the festival attendance increase each year? So to find the percent that it increases, all we have to do is look in the parentheses. The 1 is always there, so if you subtract 1, it leaves you with 0.1, which in percent form is 10% increase each year. The next one, how many people will attend the festival in 2014? Round your answer to the nearest 10,000. So 2014 is 4 years after 2010. So we'll fill in 4 for t. So into your calculator you can type 150,000 times 1.1 to the 4th power. And I got 219,615 people they would expect to attend. Next one, the function y equals 500,000 times 1.15 to the t power represents the number y of members of a website t years after 2010. By what percent does the website membership increase each year? So again, we look here, if we subtract 1, we get 0.15. Which as a percent would be 15%. And then how many members will there be in 2016? Round your answer to the nearest 100,000. Oh, this is supposed to be rounded to the nearest 10,000, which would be 220,000, I guess, for a final answer. Nearest 100,000. So 6 is 2016 is 6 years after 2010. So I type in 500,000 times 1.15 to the 6th power. And I get 101,156,530. And I get a decimal answer. So the nearest 100,000 would be 1,200,000. members. Okay, turn your paper over. Next, we're going to talk about compound interest. And compound interest is interest earned on the principal amount and on previously earned interest. So it's the same exact equation, but the initial amount is the principal. So if we want, we can write this because this is the principal. And again, we have 1 plus R is the interest rate. Over the number of times interest is compounded. And I'll explain more about that. And then it's to the n t power, and this is the same, the number of times interest is compounded. So on this first one, you deposit $100 in a savings account that earns 5% annual interest compounded yearly. Write a function for the balance after t years. So y equals, the principal amount is the $100. And then the interest rate is 5%, so 0.05. The interest is compounded yearly, so the number of times it's compounded, so that's 1 time per year. After t years, so this number and this number are the same, so that's 1 times, and then it'd be t years because we don't know how many years we're talking about. So if we wanted to simplify all of this, we would keep our 100. 1 plus 0.05 over 1, that just divides out to 0.05, so 1.05. 1 times t is just going to be t. So here's my simplified equation. Oh, I forgot to put the table. Here it is. Okay, write a function for the balance after t years. This is a money market account over time. So to write an equation, we know that we want y equals a times 1 plus r to the t power. We know a is the initial amount, so I fill in 100. My interest rate, if we go from year 0 to year 1, we can see what the interest rate is. 100 increases to 110, so we do the increase divided by the original, and we get 0.1. So this would be 1 plus 0.1, which is 1.1. And we leave to the t power because that leaves our equation general. So that's our function. And to graph the function, I would say we'll increase by ones our years and maybe 25s. So year 0 we have $100. Year 1 we have $110. Year 2 we have $121. Year 3 we have $133. Year 4. Year 5. So there's our graph. Okay, if you deposit $500 in a savings account that earns 4% annual interest compounded yearly, write and graph a function that represents the balance y after t years. So y equals, my initial amount is 500. I do 1 plus 4% would be 0.04. And it's compounded yearly, so it's t years. And you can graph it on your calculator and see what that looks like. Okay, on the back, you're going to try these two on your own. Number 1 says a credit card debt of $1,100 increases by 28% each year. Write and graph a function that represents the situation. And number 2, you deposit $675 in an account that earns 3.4% annual interest compounded twice a year. Write a function and then find the balance in the account after 2.5 years. Have a great night.